Hello everyone, I'm back. So, what we did, where we left off, is we're having this small problem that we're trying to smooth everything, and in this case, I actually did mess up some stuff because we deleted this part, if you guys remember. So, we can fix that. You can definitely delete this. We're not even using it. So we had that problem. We were having our planet was created, everything was okay, but we decided to change the way the smoothing works. So we wanted to smooth everything like it was one thing instead of smoothing each tectonic plate and then going like to do whatever. So it's not the best idea. So now we decided to let's smooth everything like it was one thing, which will create a very an actually believable planet, if you ask me. So we were having problems because here something in this line was trying to access something that didn't exist. So what we want to do now is we want to fix this. I don't know how we're going to do it, because I'm going to do a line here. I'm going to try this, and we're going to catch an exception E, and if we catch it, we're going to do log A B I. Let's do it I. B, and I also want to add info regarding the count. So areas dot count. So I'm going to I did a try catch syntax wrong. Typo. And yeah, let's use system. I mean, we were going to try catch, so yeah, we're using system. Good to do this so we don't have any errors, even though it's an error that I know will not happen. Okay, why are you still doing this? Okay. I think it was system dot exceptions. System dot try. We'll delete using system and ask for it to fix here because I don't remember the exact spelling. Here, using system dot exception. Okay, I'm gonna play. We had a lot of errors, we can see this. So when A is -1, y is A -1, I is equals 0, A is being -1, and count is 330. So we're having a problem here that we shouldn't, because we're doing -1 mod 330, and it should tell us 329, but it's telling us This is really bad. First, I'm actually going to add like this. That way we will be able to see the message. Like, we can see that now it's a lot more smooth, but here we have the error, and then we can see A -1, I 0, B 1. So the problem is being when we access A. So A is apparently not good enough. That's strange. That's really interesting. Let's try here C# reminder operator. Let's try Okay, our reminder. We need you to have a way to do this for negative numbers. And actually, why didn't we have this problem here? Oh my god. I was never moving to 0. That explains so much. Okay. They will return signed reminders. So a guy created. That should be a function for this. Okay, we will need to convert this instead of using this function, we'll need to use another one, which sucks if you ask me. So let's untag this. I don't want this to be tagged. So like we can have this in here like that, but we just need to fix these mods so they know when a number is negative to God damn it, how would we do it? So like if this is kind of this is negative, we need to do like if a less than 0, we need to make a equal areas dot count -1. And this should also work here, but instead of areas, we're doing Tectonic. Okay, there you go. The problem was the mod operator has issues with our very important negative number -1. So we had the problem there. Like on this end, we had no problem. This is like the maximum, but on the minimum, we had a problem. So now, as we can see, we have our tectonic plates and they are smooth between them. So our planet can finally start doing more complicated stuff. So what I'm going to do now is something that I think is really good for everyone to do, which is once in a while you go out of your way to backup stuff. In my case, I use Gitkraken to manage my GitHub repos. So, and here we can see the changes. So you can see that we added a lot of stuff. Also, some stuff here is not even necessary. I'm going to add everything, and then I'm going to remove that material because it's not. And here I'm going to say, actually I'm going to remove this updated actually created planets. So here we can say that we created tectonic plates, planet areas, and planets. Also updated GDD. And I'm going to take off this point because that's the way I'm doing everything. So we push, that means we're committing stuff to our repository. So now it's on my repo. So I can safely reopen Unity, and everything that I did is now backupped. So if I have a problem, I'm going to have stuff to fix it. So A, we don't need you. Here we can see our old code, everything's on its place. Just let me get real quick something to drink while we talk. So what we need to do now is we need to start thinking about populating our map with actual data, like with actual data. I mean, by data I mean like volcano, nuclear, food sources, population, stability, and humidity. So, and actually we still have something else. You guys remember that we did here on sea level, right? What I'm going to do is I'm going to create a function void set sea level, and it's going to take a float of visible, and this is going to make sense to you. So set the sea level to leave percentage visible percent of area over the sea. So basically what we're going to do is we're going to populate the list once more, and then we're going to say like I want 30% of it to be over the sea. So actually what we're going to do is we don't need to populate list. We can make int count and then int height, and actually height will be float and count equals 0, height equals 0. So what we do is for everything that we add we increase count, and then we make height plus equal planet I dot tectonic j dot height. So we're making an average. So what is the average height? What is, wait, okay, open this up again. Let's talk. So we have all of this, right? This is our big good old planet, and we're going to get the average height, and it's going to be a line, I would say on this picture around here, actually around here. And we can say that we want 30% of above average to be actually this would not be an accurate way to represent stuff. We have lots of data. If we say I want 30% to be visible, I can't say I want 30% to be visible. I say I want this over the average by this much. So average modifier to average modifier above the sea. So we have our average, which is going to show us our average height. I'm going to tell us this, which is height by count. So over here, after creating everything and showing everything, I want to do earth dot set sea level. I'm going to make 10 just so we have a number. And when I play, I want to see something here, not this. Okay, this is the average height. So I'm going to create a cube. Let's pause. Let's do this. I'm going to create a cube, and I'm going to position it on I'm going to make position 0, or y I'm going to make it 400. Here I'm going to make minus 200, so we can actually 200. So we can see it. And y, it's going to be 48.6794. And we're going to grab that number, divide it by 2, and that's our y position. So 24.3397. So this is the average. Okay, once again we're going to create a material. This is, make this like that, and since this is transparent, this is the average of height. We can see it's way bigger than we expected. So what we could do is, since this is the average, we could say, what if you moved yourself a little, I don't know, like this? So if I had, there you go. Okay, this is our actual map. So we have, I'm going to move this back to its original position. We can see that the greatest part of our thing is under the sea, because average height is, it's not small at all. What if we multiplied it by, I'm not sure. What if we multiplied it by that float that we gave? So instead of giving a 10, I would give it a 0.7, and I would set sea level to be equal height by count multiplied by average modifier. I would still need a way to get an average modifier that made sense, but I'm still going to debug this. So now we're going to debug sea level, and let's test it again. Ooh, compiler errors, the best. It was a float. It said, "Oh, I'm a float. You forgot the point, like the F." Okay. So let's create our nice cube. Put everything on 0. Our scale here will be 300. I think that's enough. Here we'll put 150. That was not enough. So we can make this. I'm going to actually automate this process. I don't I don't want to spend time, so auto sea level station. What I'm going to do is I'm going to create a game object, call sea, and it's going to be a game object dot create primitive cube Of course, this was wrong. And then C dot transform dot local scale. It's going to be, I'm going to make it 400 the default, which is pretty good. 400. Y is going to be earth dot sea level, and here I'm going to make it 2. There you go. And now C dot transform dot local position equals new vector 3. X is going to be 200. This is going to be earth sea level divided by 2, and here we have 0. So stop this, play. When we play, we'll have our cube, and I'm just going to assign its material. So this is the modified. I'm going to create, I'm going to create a secondary call it C2, and this is going to be sea level. I multiply by 0.7, so now I'm going to divide by 0.7. That way we would have 2 cubes. One of them is our sea level, the other one is our secondary sea level. So like average versus fixed. I'm going to call this fixed. I'm going to create something very like this. I'm going to create something similar but with another color so we can distinguish it. Average is going to be green. This is good enough. And we have our first one is the fixed. So now we can see this. I'm going to disable 2D so we can kind of look at it. I'm going to make this more transparent also. And rename 2D. We can see stuff from, right? Okay. Average was kind of good. And like, I wish we had more space over here, like instead of 0.7, like 0.9. So what I'm going to do is I'm going to create a public float C modifier, and I'm going to set it to 0.9 as for now. And let's put this here, replace here, replace here, and place here. So now on our thing we can check that. So come on, 0.9. Let's play and let's start looking at stuff. So average, fixed. This is pretty good. The fixed, if I disable the average, you can see like we have a pretty good landmass. I'm liking this. Okay, I'm going to disable these these two things. And I'm going to also disable this. And then we can start thinking a little bit more about what we're going to do after we have the data. Because right now, I can do this. What I'm going to do, just so we can test more stuff on here, if input dot get key down key code dot space. So if we press space, this dot start. There you go. So we can play, and if I press space, it's going to recreate stuff. Actually, not recreating, just smoothing, which is very interesting to look at if you think about it. Let's make smooth modified 1. 1 smooth, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how it looked. Let's move more. As we go, we start seeing. Not really, we don't see much difference after a while. We were not doing 10s, we were doing in series of 10s. So this is 5. This is 10, 15, 20, 25, 30, 35. You can clearly see stuff's getting like smoother. I'm gonna keep mesh in space until I see that thing popping down. Like I'm looking directly at this. After like a lot of things, like if I had this is going to take a while. Yeah, we should have like something like this, really smooth, really flat. Okay, that's a lot. So if we have 100, that's already a lot. And actually what we're doing is we weren't even destroying what we had when I kept meshing space. So I was not looking at how good smoothing was. So I need to do for each transform child in this dot transform destroy child. So I'm deleting all the children and then I'm going to run it again. That's basically it. So run once. I didn't destroy stuff. Oh, okay, I can't destroy the transform because I'm dumb. It's child.gameObject. There we go. Now we're destroying the game object instead of this transform. So run once. This is 20, 30, 40, 50, 60, and like we can clearly see this getting like smooth. So let's try running it with once and see how like 1's move fast, this is a smooth, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14, 16, 15. So this is smooth. I like it. I really do. I'm liking this. This is looking great. We can delete update because we don't need that function. And now we know how to create planets. Well, we still have to populate it. Should we populate the whole planet, or should we populate like the tectonic plates? I'm thinking if we had a function populate, actually functions, I want this populate, and we did for each tectonic plate tag in planet tag dot populate, and then we can have a function called populate inside the tectonic plate. Have a public void populate. This will go through everything inside the tectonic plate. So after creating, we go in and smooth it. So now we can do earth.populate. Sorry. Open. Come on. Open, close. There we go. Earth.populate. And then for int I equals 0, I less than tectonic dot count plus plus. Yeah, I'm going to use tectonic.count instead of size, even though we have the variable. Just because they will mean the same. Actually, I think size might be faster. I'm going to do size then. And what we're going to do is, why not, right? Tectonic at I dot. We shouldn't call this populate. We should call this like that, initialize. And then we can do all our stuff in here. The thing is, we want to. We have our functions. We can do stuff like planet calls tectonic plate, which calls planet area. Basically, we're doing planet area. Don't I want information on other tectonic plates though? We better have extra things. I'm actually going to do it here. We don't need this. There we go. And here we're going to have extra functions. We're going to have tectonic count, max tectonic size, min and max sea level, right? Max height. And we also want to have this we want to have a number that will tell us how hard it would be to, like, for the game. So our initialize function should take a float a float abundance, and we're going to pass abundance here. Actually, we're going to do random dot range. Let's create 2 floats. Max abundance and min abundance. So we're going to pass a number between min and max. And now here we take this float, and this is where we do the magic. So here we need to pass 2 numbers, min and max. I'm going to create the floats here. So modifier public min abundance equals, let's put the 10, and public float max abundance 100. Min abundance, max abundance. There you go. So float abundance, then we call it, we have a number between those 2. So that tectonic plate is going to have that random abundance level. Abundance should be relative to the number of volcanoes. Actually, we can create, I think we can create 1 volcano per tectonic plate. So first we're going to add the volcano. So on tectonic 0, that means the start. We're going to set volcano to true. So we add volcano to the beginning of, oh my god, to the start of the tectonic plate. So if we're doing zeros, we're going to have one here and then like the whole tectonic plate, and the other one here and the whole tectonic plate. So that way we don't have multiple volcanoes lying around. So there we go. We have now a tectonic volcano. And now we need to set all of this. So we still need to set, so for each planet area in tectonic, we need to set all of this. So area dot humidity equals something, area dot population, area dot soil stability, area dot nuclear. We need to have a nuclear variable. Food sources, like that. Is this all? Humidity and stability. This is the stat. We can move food sources here and nuclear below. Okay. What I'm thinking now is we should set our creation rates. So I'm going to create I want to kind of create this global parameter that everyone will see, so I'm going to create this. God damn it. Let's create it here, and let's call this RNG values, right? And actually, I'm going to create this as planet RNG values, because we're obviously going to have a lot of RNG everywhere. So we don't need any of these, we don't need any of these, we don't need any of these, and I want a bunch of variables, and I'm going to control that to control the percentage, like the RNG percentage. So I want a public float. Let's think. Let's start writing stuff actually. Every number that will determine how much of any resource is on a planet area will follow the variables in this file. And important, notice that random.range should be 0 and 100, and this will be compared with the variables here. So public float. That's called the simple nuclear probability. Actually, this is not simple at all. We're going to need to add a lot of variables here, and we're also going to need to plan ahead a lot to start actually doing stuff in here. So I'm going to save this all, and all, like, I mean everything, even the stuff that, like, with errors, I'm going to also commit it again, and we're going to start thinking a little bit about statistics, but honestly, I'm thinking of doing that another day, not right now. So I'll create this commit telling us that we are waiting for generation, waiting to initialize areas. And I'm going to say need to create variables to control area generation. I'm going to commit that, push, and okay. What I'm going to do now is I'm going to pause this. I'll take over tomorrow. I'm not going to stream anymore today. Let's see. I'll keep a channel so you guys can talk with me open. So on my YouTube, if you comment on my videos, I will try answering to your comment on a next video. And if it takes me a while to answer something, my information is on my website. I'm going to also leave a link to that in the descriptions. You can send me an email. Please put Operation Protect as its subject so I can filter it through spam and everything, because we know how emails are. If you want to ask me a specific question or give me a suggestion, I appreciate it. If you can, please join me on my streams while I'm doing stuff, so we can have that instant conversation instead of me replying to you on a video and then gods know when you're going to see it and then talk again. So if you guys enjoyed it, please subscribe to me and follow me on Twitch so you guys can follow this. Thank you for your time.